our last video we discussed about is matter pure. In this only some content only we discussed. So in this video we will continue that remaining content. So in our last video we discussed about pure substance, compounds, mixtures, and what are the types of mixtures, and solutions, concentrated solutions, and suspension, colloidal. This we discussed. In this video we will discuss separating techniques. Means in our last video we discussed about types of mixtures. Mixtures means one or two or more substances combined together, mixed together, they forms mixture. For example, now take one substance sugar and one substance water. So when we mix this sugar in water, what happened? It's become into sugar solution. That is one type of mixture. Why? It is containing two substances. So take salt, sugar and water. If you mix it these three, then it is also mixture. So now our problem is we want to separate again. How to separate this sugar, salt, water we mixed? So some techniques are there to separate these mixtures. So that we will discuss in this video. So this is separating techniques. The first technique is sublimation. First you have to know the definition of sublimation. The process of conversion of solid into gas without liquid state is called sublimation. Means we have actually three states. So what are the three states? Solid, liquid and gas. So when we heated solid, it will convert into liquid. After that it will again, if you heat more and more, then it will convert into gas. Actually that is the process of states. But here according to sublimation, the conversion, it is directly converting from solid to gas without liquid state. It is called sublimation. So we can separate two substances by sublimation process. See here, you learned already in the 7th class this process, this sublimation process. Here I took one candle light. So here this is a china dish. In this china dish, we should take two substances. We should mix two substances. Then only it's become into mixture. So here this is the substance. It is containing mixture of ammonium chloride and salt. Two substances are there. So it is mixture. So this mixture I took in the china dish, and this is the funnel. Funnel I took here. This funnel, it is closed with cotton plug. So now what I did, I heated this ammonium chloride and salt. So when I heated this ammonium chloride and salt, first you will observe the fumes of the ammonium chloride. And after that, when we cooled this apparatus, then what happened? The fumes of the ammonium chloride, it will be appear on the walls of the funnel. Sulfied ammonium chloride, it will be appearance on the walls of the funnel. So you did not observe any liquid state of ammonium chloride. You will see directly that ammonium chloride first convert into gas. So again it will convert back into solid ammonium chloride. So now you separated that ammonium chloride will be present here and the salt will be present here. So you separated that ammonium chloride and salt by using sublimation process. You see, it is one type of separating technique. Another technique, that is evaporation. So for understand this evaporation, you should do one experiment. Here you take one stand. On this stand you keep one beaker, glass beaker. In this glass beaker you just add some quantity of water. So take one watch glass. So that watch glass keep on the beaker. In this watch glass you take some quantity of ink. So now what we will do, we will heat this beaker. So what happened, when we heated this beaker, you will observe some changes. What are the changes you will observe? Actually here in this watch glass, what it is containing? ink. Ink means this ink, it is containing a high amount of water and less amount of ink, means ink it is mixed with water here. So when we started heating this beaker, what are the water content this ink it is having, that water it will be evaporated. Finally you will observe the residue of ink on the watch glass without water. That means by using evaporation you separated ink from the water. So two substances are there. What are that? Water and ink. So you separated these two substances by the process of evaporation. Can you guess ink? What it is containing watch glass? Ink and water. So can you guess which is solvent and which is solute in that substances? In our last video we discussed solute and solvent. So which is less quantity, that is solute. Which is high quantity, that is solvent. So ink it is less quantity, so it is solute, and water it is solvent. So ink is a mixture of solute and solvent. What is that solvent? Water. In ink a single color only present. So in the ink you will observe only single color, or any other solutes also there in the ink, that we don't know. So how many solutes are there in the ink, that we don't know. We are observing, for example, it is black color ink, so we are seeing only black color. Is any other solutes are there, that we don't know. So how many solutes are there in ink? How can we find out those? So how we can see how many solutes are in ink? That is another technique we can use to identify how many solutes in one single ink. See another technique, that is paper chromatography. In previous I said in the ink how many solutes are there. Actually visually we are seeing, if it is black color ink we are seeing only black, if it is blue only blue. But is any other solutes are there in the ink, that we have to identify by using paper chromatography. You just take one beaker. In this beaker you just take some quantity of water. So and after that one filter paper required, and pencil. These are the requirements. Cello tape. These are we need mainly. So you just take one marker. You just take one filter paper like this. You cut this filter paper and draw with pencil one line like this, and you dot on this line with marker or ink, any pen. With any pen you just give symbols like this, and you just keep this filter paper into the beaker like this along with pencil, and you keep cello tape to fix that filter paper. You just take one cello tape like this. So keep this beaker some time. After 10 minutes just you take out this filter paper and observe. So what we will observe, you kept that marker spots here. So this marker spots it will come from bottom to top like this with different colors. So previously we will see only black color spots, but when we keep in the water, after some time if you observe, we will see different colors in that black color ink or blue color ink. That you understood, ink it is not only containing single color, it is containing different colors. Those different colors we can observe by paper chromatography. So this paper chromatography is used for separating colored substances. Another technique, that is separating funnel. It is used for separating immiscible liquids. That means which liquids are not mixed together, those we can separate by separating funnel. See here it is a separating funnel. Just you keep one stand here to attach this separating funnel. So this separating funnel, it is now I took some quantity of water and kerosene. What happened? Kerosene and water, these two are not mixed together. That means those liquids we can call immiscible liquids. Those liquids are not mixed, those we can call immiscible liquids. Water and kerosene, these two are not mixed. Kerosene, it will be float on water because kerosene it is having less density than water. water it is having high density than kerosene. So water it will be appear on down position and kerosene it will be appear on top position. So when the here it is the outlet, so first the water it will come dropwise in the down. Just you keep one container here, dropwise the water it will come out. So when it is reached up to here, then here one stopper will be present to this separating funnel. One stopper will be appear here. So when the water come up to here, so we can stop by stopper. So we can separate kerosene and water by using separating funnel. So very important question. They will ask you how can we separate immiscible liquids? Which operators we can use for separating immiscible liquids? So what is that operate? Separating funnel. Another technique, that is distillation. It is used for separating miscible liquids. So previously we discussed about immiscible liquids. Immiscible liquids means the liquids which are not mixed. Those we can call immiscible. Miscible liquids means the liquids which are mixed completely together. That we can call miscible liquids. Those are separated by distillation. For example, if you see here acetone and water, if you mix these two are completely mixed together. We can't find out which is water and which is acetone. In that time, if we want to separate these two, we can use a distillation process. So here in the distillation process, acetone it is having less boiling point. Less boiling point means liquid it will convert into gas. So acetone it will convert liquid into gas very fastly than water. So first acetone it will be evaporated. So if it is evaporated, then finally in the beaker what we will get? Water. So we can separate water from the acetone by using distillation. And another technique is fractional distillation. It is also working based on that boiling points. Which is having less boiling point, it will convert very fastly into gas. So which is having less boiling point it will be. But here what is the difference here? If the variation is very less, if the substance's boiling point variation is very less, then we can use this fractional distillation. It is used for separating when the boiling points of the substances is less than 25 degrees Celsius. So more than 25 degrees Celsius, then in that case we can use distillation process. So if the substance's boiling point is less than 25 degrees Celsius, so this distillation process it will not work out. In that case, we can use fractional distillation. This is a very important question. In the fractional distillation, what type of substance boiling point difference is? What is that difference? 25 degree Celsius. In this video, we discussed about separating techniques of the mixtures. In this, if you see in the textbook or any other materials, the diagrams of related to these techniques are very clear. You check once the textbook and or any other materials what you have at home. Check once the diagrams and everything was very clearly they draw in the textbooks. Thank you very much.